So in this video, we are going to take a look at how to use a linear regression to build a machine learning model in order to help to predict electrical energy output for a combined cycle power plant. A combined cycle power plant uses two different thermodynamic cycles to produce electricity, namely the gas turbine as well as the steam turbine. By utilizing this, it can achieve more efficient and cost-effective use of fuel as compared to single-cycle power plants. The electrical energy output of a combined cycle power plant can be influenced by various ambient environmental factors. Therefore, in this project, we have been given 4 environmental ambient factors, namely temperature, ambient pressure, relative humidity, and exhaust vacuum, to try to predict the electrical energy output. For the modeling approach, we have chosen the linear regression, and this is very simple because linear regression is best used for predicting a continuous target variable based on one or more independent features, and I provided the details in the table below, showing the features that we are going to use in this project as well as the target variable that we are trying to predict. For the model building, I have split the data set into a training set with 70% of the data, as well as a test set for 30%. The training set is used to build the model, whereas the test set is used to evaluate the performance. I have done the model training with different number of features and evaluated the effectiveness of the model using the mean absolute error, mean squared error, root mean squared error, and R-squared data. Here are the respective outputs for the different models using the different number of features 2, 3, and 4. I compared the efficiencies across the 3 models and noted that the model C has the best efficiency. The indication of a lower MAE, MSE as well as RMSE indicates that it is a better comparing model, because this matrix directly measured average error or deviation from the predictions, and therefore we want that number to be low. A higher R-squared closer to 1 also indicates that it is a better fit. I then ran the model on the test set and noted that the R-squared is almost close to 1, so there is better optimacy on this. And there were also improvements across the MAE, MSE as well as the RMSE. So if you're interested in how I have evaluated the model, you can kind of view the details of it here. In the above description, there are different explanations of the matrix that I use to evaluate the model. Last but not least, it is important to understand the business use case of how this data and machine learning prediction model can help for a business. It can help the combined cycle power plant to design a better system to operate within the range of environmental conditions, and the engineers can also use these factors during the design phase to optimize the performance and ensure that the plant can handle variations in the ambient conditions. Understanding how the electrical output is affected by ambient conditions helps them to provide efficiency improvements, advance and use advanced control systems, as well as also to drive predictive maintenance and energy forecasting. From a data analytics point of view, we can also look at including more features such as air quality, wind speed, solar radiation to see if it can improve the model prediction. Perhaps adding more features or interchanging the features may help to improve the predictability of the model.